All right, 4.3, multiplying and dividing rational expressions. So, excuse me, it's an old cough, not a new one. Steps to multiplying rational expressions. So first step, factor all the numerators and denominators completely. Okay, really, that's exact same as simplifying, right? State the restrictions from the factored form. Again, exactly the same as simplifying. Divide out common factors between a numerator and a denominator. Almost exactly the same as simplifying, but this time it's any numerator with any denominator, right? And you'll see that as we go through. Any numerator, any factor that's in the top can be canceled with any factor that's in the bottom. And express answers as one rational expression. Okay, if it's a division, then you have to do one step first. Take the reciprocal of the divisor and show it as a multiplication, right? So kiss and flip. And then really, okay, that's not exactly. And then just follow the steps, right? So write it as a multiply first, then factor it, then state the restrictions, then divide out the common factors, and then express it. Okay, so one is just doing non-permissible values, right? And you know what, we're going to cross that off. Instead of non-permissible values, let's just say we want to state the restrictions. State the restrictions. Okay, where are we? So we got to look down here. So x cannot equal -4. And this is going to be 1/5. All right, and if you're okay, how do you do that? Well, remember, so what we do is we set it equal to 0, which is really the way that we would find a non-permissible value. Then that becomes 5x equals 1, and x is equal to 1/5. Okay, so you set the denominator to 0, and you solve for the value of x. X equals 1/5, that's the non-permissible value, but generally we do restrictions, x cannot be 1/5. Okay, this guy here becomes a multiply. So the first term stays, 2x squared over 5, times, so that's the kiss, times, and then we take the reciprocal, that's the flip, over x cubed. Now this question is really just asking for the restrictions or the non-permissible value. So we're going to look down here. There's no restriction there. Look down here, say x cannot be 0. But we also have to look up here, because up here was down there. This was in a denominator position down here. So that's going to be, and I'm not going to show this one, -1/3. -1/3. So basically, excuse me, you're looking in 3 places. This denominator, this is a denominator, and when it's over here it was a denominator, and this will become a denominator. So really, the only place you're not looking for restrictions is the top left. You don't have to look here. Everywhere else you have to look at for restrictions. Simplify. Monomial rational expressions, remember to state restrictions. Okay, any monomial is just going to be x cannot equal 0. The variable can't be 0. It's a monomial. Over here, y cannot equal 0. Over here, x cannot equal 0, right? It's just basically, if there's a variable in the denominator, that can't be 0 in a monomial, right? Monomial, one term. And then what we can do is, you know, I have 15 over 10, so I'm just going to pull out the calculator. I'm going to make that a little bit smaller here. So, you know, I can go 15 divided by 10, math, enter, enter, right? Change it to a fraction. Notice it's 3 over 2. So 15 over 10 is going to be 3 over 2. And then x to the 5th over x, well, that's bigger. And how much bigger? 5 minus 1 is 4. This one here, 24 over 40. Okay, same deal. Let's go 24 divided by 40. Math, change it to a fraction. Math, enter, enter, changes to a fraction. Right, we get 3 over 5. So 3 over 5. Y to the 6th is bigger, right? So our y ends up down here. How much bigger? 4. Right, 6 minus 2 is 4. Negative 12 over 3. Okay, that's positive 4. Now, that would be 4 over 1. So we got to see what we have here. So the x to the 5th is bigger. It's 1 bigger. I don't need to write a 1 here, right? So I just got that's bigger by 1. So the winner is the x on the bottom. Okay, and all of these have this restriction. So even though here x can be 0, it can't in the original expression. Okay, remember, it's always the factored form before we do any simplification. We have to state the restrictions. Simplify, remember to state restrictions. So, with monomials, the easiest way is just to multiply this out. So I treat this as 2x over 1. And this will give me 30x squared over 25x squared. Okay, now before we go on, let's go do, it's just a monomial, right? So just the x can't be 0. And you can use your calculator or not. 30 over 25 is 6 over 5. The x squareds just take each other out. Okay, so there is no x term left. So whatever you put in for an x here, you're always going to end up with an answer of 6/5, right? As long as you don't put x as 0. So if x is 1, you see we're going to end up with 15 times 1 times 2 times 1 is 30 over 25 times 1, 30 over 25, 6/5. Here, okay, let's just do the same thing. Let's just multiply it out. And 36 times 5 is 180 m. I've got to add to the 5th. 72 over 180. Okay, hey, we got calculators. Let's use them. 72 divided by 180. Math. Enter, enter. That's 2/5. So 2 over 5. Bigger one in the bottom. How much bigger? 3. Okay, m to the 5th, m squared bigger is in the denominator. It's 3 bigger. This is a divide. Okay, first step, change it to a multiply. Over 6a times 9p over 5p to the 4th. Now, got your restrictions here, right? It's just m cannot equal 0. And here we do restrictions now, so a can't be 0 and p can't be 0 and p can't be 0. Remember, we have to look here, here, and here. So a cannot be 0 and p cannot be 0. Let's multiply this out. We get negative 36 p cubed, right? Multiply powers with the same base. You add over 30 a p to the 4th. Now you can plug that into your calculator if you want. So 36 over 30, or you can go negative 36 divided by 30. This is the 6. I'm missing things here. 36 divided by 30. Enter, enter. And we get negative 6/5. You can put the negative out front. I kind of like them out front. Negative 6/5. There's an a in the bottom, and there's a p in the bottom. So the a, because there's no other a, and then p to the 4th is bigger than p cubed by 1, so negative 6 over 5 ap. Simplify. Okay, we have binomial numerators and denominators. Remember to state restrictions. Now, what's happened in this case is everything's in a factored form, so we just have to look at the factors, right? So step 1, factor, done. Step 2, denominators. Okay, so x squared, so then x cannot equal 0. X plus 6 can't be negative 6. X squared can't be 0. You don't need to state it again. You only need to state them once. Okay, and what can we do? You know what we can do? We can start off by crossing off the x plus 6 with the 6 plus x. Okay, it's in a factored form. And now what I would do is just multiply. So 2x times 14 gives me 28x. And the 3x minus 1 that's up top. And down here, 7 times 8 will get 56x to the 4th. Okay, now we can simplify that. So 28 over 56 is going to give you a 2 on the bottom and a 1 up top. I'm not going to write the 1. X and x to the 4th, well, who's bigger? The bottom by how much? And what's left up top? 3x minus 1, this expression here. Okay, so the 28 simplifies out with 56, giving you 2 on the bottom, the x and the x to the fourth, give you the x cubed, and we're left with 3x. And we no longer need to keep brackets around it because this term is gone. And we've got our restrictions. Divide. Okay, first step before you do anything else is just to change it to a multiply. Times 3 minus 4t. Okay, this is something we saw simplifying the other day. 1 plus 4t. Okay, so restrictions. We have to look here, here, and here. So 4t minus 3, t cannot be. So remember, move this over, it becomes 3, or change that sign. So 3 over 4. This guy's a little tougher because the signs are reversed and that, but you can just, just walk over here. Equals 0, negative 4t equals negative 3, t is equal to 3/4. Oh, so it's the same. And then we've got this here, 1 plus 4t, because that's now in a denominator. Okay, and that's going to be negative 1/4. Okay. Bing, 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 before we start. So here's the deal. 4t plus 1 is the same as 1 plus 4t, right? Order that you add things doesn't matter. These guys, no, we've got the 4t and a minus 3, and here we've got the plus 3 and the minus 4t. What do? We know this. We cross that off. We cross this off. We put a minus 1. 4 goes into 8 twice. So we got a 2 times a 1 times a minus 1, which is negative 2. And on the bottom, we've got 1 times 1 times 1. So it's just negative 2. This whole thing here, no matter what value of t you put in, as long as it is not 3/4 or negative 1/4, you're going to get negative 2. Let's give that a shot. What if we put a 0 in here, right? So that'll give me 8 times 1 over minus 3. So I'll have, let's see, we got 8 over negative 3 times, I'm going to flip that over. So we'll get 3, right? We make that 0 over 4. So the 3's cancel, the 4 goes in the 8 twice, and we get negative 2. Okay, so that does work. At least, for using 0. But it'll work for any number except for these values of t. All right, part C. Step 1. Okay, so it's multiply. So step 1 is factor. So 2. We can put an equal sign down because this is equal to 2a, actually, right? A minus 4 over 6a plus 2 times a squared minus 4 is a difference of squares. I guarantee you're going to see a few of those. Common factor here. Okay, so step 1, factor. Step 2, restrictions. I'm just going to write them up here. X cannot equal negative 2, positive 4. Okay. Common top and bottom. That's 1. That's a 1. A minus 4. That's a 1. That's a 1. I could do a little more simplifying, but you know what? Let's just go with, I've got 2a times a minus 2. 2a, a minus 2. 6 times 5 is 30. Okay, so the 2. So we get a times a minus 2 all over 50. So as long as a is neither negative 2 nor 4, okay, try a is 0 again. I was like using 0 because it's just easy to work out, right? This will just be, if a is 0, this whole thing is just 0, right? But so that'll be 0 divided by 12, which is 0, and that'll be negative 4 divided by negative 20. 2a squared. All right. That'll be 0 divided by 12 is 0. Oh, 0 times anything is 0. That would just be 0. But this actually would be some number, right? But it's going to work out to 0. Okay, it's a divide. Step one before you do anything else. We're going to put down an equal because this line is the same as what's here. And I'm not going to do anything else. I'm simply going to kiss and flip. Okay, then we'll do the restrictions. Okay, it doesn't matter where we list them. Oh, sorry. No, now we got to factor. So 10x cubed. So 2x squared. It's a case where it's just a great common factor, right? 3x to give me the cubed. Okay, minus 5. Times 12 and 20, so 4. And I'll give 3x minus 5. So this is not a surprise because we would have wanted something to cancel with. And then next to the 4th. Since it's a divide, we're looking here, here, and here. So this doesn't really matter because these guys are the same. So now we can say x cannot equal 0 or 5/3. So it can't be 0, it can't be 5/3, it can't be 5/3, it can't be 0. You don't repeat them, okay? Okay. Let's simplify out some stuff. Okay, let's just multiply now. So we're going to get 40x cubed over 2x to the 6th. Okay, so just look at what's left, right? That's a 1. So I have 10 times x cubed times 4 is 40x cubed. I have 2x squared. That's a 1 times x to the 4th. 2 goes into 40 20 times. X to the 6th is bigger by 3. So 20 over x cubed. Okay, next one. Multiply. There's common factors there. Common factor there. That's a difference in square. Okay, so let's start factoring. So this top here, okay, we've got this, and this numerator will be 2x plus 3. Okay, so you have to recognize this is a difference in squares, right? Two terms, both squares separated by a minus sign. 4 is the common factor. X plus 3. 2x squared minus 18. You know what? Here, I'm going to do this first. We'll just go 2x squared minus 9. So it's 2, then x plus 3, x minus 3. Okay, so just recognize, hey, there's a common factor. This will factor to be this. This is 2, and then we've got a difference in squares, x plus 3, x minus 3. That's a 3. Doesn't look very 3-ish, but it's a 3. Okay, restrictions. So to multiply, we're not looking up here, we just look here. So negative 3, and here 3/2. Okay, again, remember, so what I do is I set 2x minus 3 equal to 0, 2x equals 3, x is 3/2. That's the non-permissible value stated as not equal to. Now it's a restriction. Okay, I just like to let's get rid of the binomial factors, right? 2x minus 3 to 2x minus 3. Okay, so we're left with a 2, a 2x plus 3, and an x minus 3. And over here, we're left with a 4. 2 goes into 4 twice. So don't expand this out, right? Whenever we simplify, we don't want an expanded form. So there's your final answer. That is your simplified form. It's always a single rational expression. And keep in mind that these restrictions go with this. Right, two rational expressions whose quotient. So the quotient is the act of dividing, right? So, do that. Go away. Go away. How did you get in? Okay, it's gone. Back. Stop touching. So product is multiply. Quotient is divide. So I want two rational expressions whose quotient is negative 6. So they'd be like this here, right? Like this is negative 6x over 5. So okay, so, let's say we want to do something like that. I'm just going to write this over here. If we had like a over b divided by c over d, we want that to equal negative 6 over 5, right? So if you think about this, if that's dividing, then if we multiply both sides by the reciprocal times d over c, then this expression here, if you took this and divided it by, why does that say d over c? If you take that and divided it by d over c, okay, then you would end up with this. So as long as these work. Okay, so let's do this. Along this line, let's say we take negative 6x over 5, and let's just keep this simple. Let's make this 4/3, 4 over 3. So we get negative 24x over 15. So if we took negative 24x over 15 divided by 3/4, times, well, that it would be times 4/3. So we're going to have to divide by 4/3. Hang on, I have an eraser here somewhere. Okay, so if we take that and divide it by that, it will equal negative 6x over 5. Right, so just to check that, negative 24x over 15 times 3/4 is going to equal, so 4 goes into that 6, 3 goes into that, that's 1 goes into that 5, we'll get negative 6x over 5. X is there, and that's 5. Okay, and we can do that one more time. So let's pick a little more complex expression, negative 6x over 5 times, let's go 2x minus 1 over 3x plus 2. So that's going to equal, so if we actually expand this out, let's do this, we'll get negative 12x squared plus 6x over 15x plus 10. Okay, so that's our a over b, right? So if we take negative 12x squared plus 6x over 15x plus 10 and divide that by over 3x plus 2, the result will be negative 6x over 5. I highly doubt you're going to see anything like this, right? But it's just an idea of, hey, how does how does division work, and how would you find stuff? So that's your a over b, and then you've got your c over d there. And so if you factor this, okay, this is already factored. If you factor these guys, so that means you factor this, you're just going to get back to this expression here, right? And this expression here, and then if you divide by what you were multiplying by, you're going to get back to the original. Okay, so that is it for multiplying and dividing.